Hello there, this is the Maths Tutor Online. I hope that I find you well. This is a tutorial on the transformer. We're going to be talking about alternating current electricity. This is a very paramount topic when it comes to mathematics, physics, chemistry. Okay? You want to study to be an engineer, you want to study to be an automobile electrician, you want to be a technician, you want to work in the power utility industry, electrical engineer, or you want to be a rocket scientist, this will be a good lesson for you. You want to be an electrician and fix electrical wires, the installations in your house, your neighborhood, your country, and you want to serve your nation, this will be a good starting point to boost up your practical knowledge. Okay, so if you want to get good grades, you can join me on this short tutorial. Okay, so basically a transformer consists of an iron core, a soft iron core, with what you call the primary windings and what you call the secondary windings. Okay, the primary windings are where the EMF, electromotive force or voltage, goes in from whatever source of power is generating it. The secondary side, which is secondary number of turns, is where you have your output voltage. As you can see, there is V input and V output voltage. So there is what you call a step-up transformer and a step-down transformer. As you can see here, the voltage is 10 volts in, coming out it's 6.67 volts. So that's what a step-down transformer is. A step-up transformer is one that increases the voltage so that the output voltage is greater than the input voltage, whereas a step-down transformer is one that reduces the input voltage into the transformer to a smaller output voltage. Okay, so let's go back to the theory of the transformer, which says the primary coil produces a varying magnetic field through the soft iron core of the transformer. The changing magnetic field induces an electromotive force in the secondary coil. If the number of turns in the secondary coil is greater than the number of turns in the primary coil, the induced EMF will be larger than the input voltage to the transformer. This is called a step-up transformer. If the number of turns in the secondary coil is smaller than that in the primary, the EMF will be smaller. This is known as the step-down transformer. But the important formula to remember with transformers is the ratio of voltages will be equal to the ratio of the number of turns on the two coils. V output over V input is equal to N output over N input. A transformer does not create energy from nowhere. The increase in voltage is achieved at the expense of the current. If the output voltage is greater, the output current will be smaller. Large transformers can be very efficient, and in an idealized situation where there is no power loss, we can say that the power input is equal to the power output. V in times I in is equal to V out times I out, where V in is the V input voltage, I in is the I input voltage, is the input current, V out is the output voltage, and I out is the output current. Therefore, I out over I in, which is the output current over the input current, is equal to the number of turns of input over the number of turns in the output coil. Bear in mind, this time they've switched. Initially it was V out over V in is equal to N out over N in. Now it's I out over I in is equal to N in over N out. So please don't confuse these two formulas. If you want to know the derivation of how we came here from there, you can contact the Maths Online tutor and I'll be more than willing to assist you. So bear in mind, using the previous ratio, V input over V output, which will be 10 over 6.67 should be equal to the primary terms, which is 60 over 40. So convince yourself that this over that ratio should be equal to that ratio over that ratio, which should be equal to the output current that over that ratio over the input current. Okay, so let's just do a virtual experiment and see what happens when we increase the input voltage okay, currently failing to increase the input voltage. Okay, but let's see what happens when we increase the number of tens to 100. Okay, you see what happens now? V input over V output is 10 over 4, which is equal to number of tens, 100 tens over secondary tens, 40. So you can see that this ratio 10 over 4 is equal to 100 over 40. And make yourself see that the ratio of output current to input current will be equal to 10 over 4. So punch in your calculator 2.88 divided by 1.15. And you can hit me up and let me know what you get on your answer. So that's just a short tutorial on the transformer. This video is brought to you by the Maths Tutor Online, courtesy of eSchool. Okay, I hope that you enjoyed the lecture and the lesson. Spread word, hit me up for more in-depth studies. Okay, standards rates apply. Okay, and if you feel like these tutorials are going a long way in helping the less privileged, you can contact me and make your donations. Thanks for watching and happy studying.